even if we begin to start, just to see we draw a picture just to orient yourself what's going on here. Okay, so we have a line, equation of a line, negative 1/2 x plus 3. What's the y-intercept? It's 3, right? 3, so let's say it's here, positive or negative slope? Negative, so it's going down, right? So just, your line doesn't have to be accurate, you just want to see what's going on here. Then we have a point, 7, 7, out here. So what is it that we're trying to do? We want the shortest distance from that point to our line. So we just draw it out. It may look something like that. So we want the length of that red line. How is it that we can calculate the length of the red line? What's the second thing that we need? Audrey?
Sorry, don't you just use the length formula?
Yeah, we need a length formula. What does the length formula require us to have?
2 points.
2 points. How many are we given here?
1.
So where's that second point going to be?
I mean, opposite.
Well, that's the line, but the point itself. Like, where's the point itself? We want the shortest distance from the blue dot to the green line. Where's the actual point itself? Yeah, it's on the green line where the red meets the green. Where the red meets the green. I mean, that's the... To get that distance, we need that second point. Okay? So I mean, that's half the challenge of this question, is recognizing that we need that second point. But how are we going to get it? Well, that's one line. Is the red? If you don't need the laptop, I'd rather you write you down the notes. See that? All right? So you see what's going on. Okay, you remember. So the red line, that red segment, you can also consider a line. Right? I stick arrowheads on top of here, and that could be a line. So what are we noticing here? How many lines do we have? 2, and we're looking for what? Yeah, we're just really looking for that point of intersection where that blue dot is. Okay? Well, what is it that we need to get point of intersection?
2 equations.
Yeah, 2 equations, right? Remember way back in that first unit when I got you to solve linear systems? If I gave you one equation, could you ever figure out what x and y equals to? No, you needed 2 equations. Well, we're given one. So we're given an equation to the green one. How can we get the equation of the second one? And this is the second challenge for this question. How can we get the equation of that second line?
What is that equation for slope?
That's the line in the green
Oh,
line.
the line.
The green line, y equals negative 1/2 x plus 3. That's what we're given, right? So what was the equation of that second? How can we get that equation of that second line, the red line, right?
That green line slope.
Why are we looking for the negative reciprocal?
Because the equation of the line you're trying to find, the slope would be perpendicular to the green line slope.
Okay, right. So I mean, that was the key concept that we talked about. Shortest distance from a point to a line has to intersect in a 90-degree angle, right? I mean, that was a key concept. We're not going to tell you that. You need to remember, this needs to be a 90-degree angle. So now we're going to work on the red one. So we need a second equation here. Y is equal to, well, what's the slope of that one going to be then? What's the slope of that red line going to be? Our triangle always hinted to us what we're looking for. What's it going to be? What's the slope of that red one? Sorry, isn't it what? Yeah, but you're gonna plug in 7, 7 to the green line. Is that 7, 7 on that green dot? Sorry, on the green line?
No, it's on the red line.
So we need the equation for the red line. Well, what's the slope of that red line?
We don't know.
Well, we sort of know. Tran gave us a hint. Ginny?
It's 2.
It's 2.
1 over 2.
Oh,
if
because
you
the
wanna be
negative reciprocal.
Right, so we took the negative reciprocal of negative a half. Right, so you can even write over here. Slope perpendicular to that is 2, right, which we plug into here. So now we have a starter equation, y equals 2x plus b. And now Cecina sort of jumped the gun a bit and says, well, now we have a point on that line, which happens to be 7, 7. We plug that in to get our value for b. I mean, this is grade 9 math here, right? And I wish sometimes this gets taught in grade 9 because you learn how to do it, but you don't know how to apply it yet. So here we got 7 is equal to 2 times 7 plus b. So we got 7 is equal to 14 plus b. We subtract 14 from both sides. So I'm left with b is equal to negative 7. So my second equation is y is equal to 2x minus 7. So how did I get that point of intersection now? I got my two equations. Yeah, I like to use substitution. So we have one equation here. And the other equation is right here. So working it out, I got y is equal to negative 1/2 x plus 3. So I'm going to take y is also equal to this here, so I'm going to substitute this in for y. So we get 2x minus 7 is equal to negative 1/2 x plus 3. Now how is it that I solve for x? Just like I got rid of my y, how do I solve for x now? Okay, step me through this, how to solve for x. Anyone? Just want me to do it? Well, how can I get x by itself? I want to solve for x, I want to isolate for x. So how can I at least start?
Isolate x.
Okay, how can I start?
By putting x on the side.
How can I do that?
Bring it over. Make it negative.
Bring what over? Don't bring things over. So you're gonna add, first we're gonna add a 1/2 x to both sides, so you can get rid of, get rid of that one. So you got 2x minus 7 plus a 1/2 x is equal to 3. So a little bit closer to just getting x's on one side. I got a negative 7 on the other side. So what does it I want to do now? Don't move.
You add the 7 on the
Good,
side.
because you know what? Some of you could have literally moved the negative 7, and you got 3 minus 7 on the other side. You can come up with the wrong answer. So we want to add 7 to both sides. Right? So we got 4 over 2x plus 1/2 x is equal to 10. So that gives me 5 over 2x is equal to 10. So how do I isolate for x here? 5/2 x is equal to 10. Okay? Go multiply 2 on both sides first. I'll show you a little shortcut. This is going to amount to the same thing. Here we have a fraction in front of x as a coefficient. Just multiply by the reciprocal. So you got 5 over 2. I'm going to multiply by 2/5 to both sides. What happens when I multiply the reciprocal? Those cancel and then just get a coefficient of 1. Now I get 10 over 5, 10 times 2/5. So that cancels to 2. So 2 times 2, x equals 4. Now to solve for x equals 4, how do you get y? because I need that y value now. I need my coordinates. You see that?
We use the same equation as other axis equation.
Which one?
The y equals -1/2 x is 3.
Sure, we could use that one. So y is equal to -1/2 x.
You could use the other one too.
Yeah, you could use either. I like using the original one because it's given to me. So what was it? -1/2 x plus 3? So y is equal to -1/2 times 4 plus 3. So I'm left with y is equal to -2 plus 3. So y is equal to 1. So therefore, my point of intersection, 4, 1. So how that relates back to our diagram is that this point, although it doesn't look like it, is 4, 1. So we did all that work just to get to that point, just to find that point. This should be the easy part now, hopefully. And it's actually applying what we just learned in this unit. How do we get that length now? Okay? Yeah, which is?
x2 minus x1 squared plus y2 minus square root.
Or that gives you L, right?
Yeah.
So we get L is equal to the square root of x2, so 4 minus 7 quantity squared plus 1 minus 7 quantity squared. Look at the square root of -3 squared plus -6 squared. Look at the square root of 9 plus 36 is equal to the square root of 45. Right? This is why you don't need your calculators. Like square root of 45 is acceptable answer. Want to simplify this radical? So that's the same as 9 times 5. 45 same as 9 times 5. So square root of 9 is just 3, 5. So therefore that is the distance of the shortest